So the least squares regression, we're going to use the TI-nspire CAS for this, and we're also going to do it by hand if we know the mean, standard deviation, and also the R value. The first thing we got here, if we got a CAS, we're going to draw a scatter plot, as hopefully you already know how to do. If not, look back, look at how to draw scatter plots on your CAS calculator. But you'll also see that in this video as well, I suppose. You need to follow the following steps once you've got your scatter plot drawn. Menu, analyze regression, show linear a plus bx, and it will give you this straight line. Depending on how new your operating system is, it may come up with R squared as well. It may not. You can have your calculator updated to come up with R squared if need be. I have said about CME for this because this is what I originally gave out to my own class. If you find R squared, notice it's R squared and not R, so it tells you the variation, in this case in height. You would have 48.37% of the variation in height can be attributed to the variation in age. It doesn't tell you the strength of the correlation. However, if you want the strength of the correlation, as this is R squared, do the square root of R squared and it will tell you the R value, and then you can go back into the table, which hopefully you've got, to tell you how strong the correlation is. When you get the correlation for general maths for year 11 at VCE, you have it in the form of A plus BX, which we'll cover in a moment. You might have used MX plus C in year 10. For year 11 and year 12 in VCE, we use this formula. First number tells you the y-intercept. So in this case, if it was 53.98, we expect the height at age 0 to be 53.99 centimeters. The number on the end tells you the gradient, and that tells us how much we expect the y variable to go up or down for every one of the x variable. So because this is 6.68, we expect the height to go up by 6.68 because it's a positive centimeters for every increase in one age. Or you could say for every year that someone gets older, you expect their height to go up by 6.68 centimeters. So what we're going to do now, we're going to go to a CAS calculator, and we're going to put this information in. So what I've got here is just numbers I've made up. It's age and its height. It's in a table. If you're not sure how to create the table, go back, look it up, find out how it's done, but we're not going to cover that in this particular video. From here, we want to make a scatter plot, so you can either go to your home page and choose your page to make a scatter plot, or go to control and your new page gives you your whole list of things. We want data and statistics, whether you pick that from the home page or there, and we end up with something like this. Y variable, X variable. X is explanatory, so if we had height and age, our age is going to explain a change in height, so height is going to change in response to age, and we've got a scatter plot drawn. We have to add a regression line to it, so following those dot points up the top, we go to Menu, Analyze, Regression, and then for further maths, we should be doing it, or general maths for year 11, we should be doing it in A plus BX form. So we've got our equation y equals 30.849 plus 6.401x. When we go back and write that into our actual question though, we're not going to use y and x anymore because x was age. We replaced the word or the letter x with age, and we replaced the letter y with height. And what I've done on the side is just quickly written down the equation that we worked out from our calculator. The other way you can do this by hand, so if you got it with original data, put it in your calculator, find your scatter plot, find your regression line, by far your easiest way to do it. It's possible you might not be given the original data, and it's possible you might be given means, standard deviations, and R values. If you're given that information, then we have to calculate it by this form. Now, this form would only be used if we don't know the original data, because it's not quite going to be as accurate due to rounding off. But if we've got this information, this is what we need to do. So we have to find this information first, or be given this information. The example down the bottom, I can see 2 means, an R value, 2 standard deviations. It tells me it's going to be this type of question. One thing we've got is that R squared. If you're given R squared, or you're given the coefficient of determination, to find R, find the square root of whatever R squared was. It will give us whatever R was. Right, if it's a worded problem, your best bet's to write the symbols out beside them. So X bar is the mean of the explanatory variable, Y bar is the mean of the Y variable. Right, our steps that we're going to do, and we'll do this over on the side in a minute, is we find the slope or the gradient first by doing b, which was from our equation of y equals a plus bx. We find the b first, which was the gradient, using this formula. We'll then find r using this formula, which requires us to have the b in there, and then we substitute it into equation to find our actual equation. So this is the example we're going to work through, the height and age of children. So we want to know what explanatory is, what is response. So height and age. Does someone's age explain a change in height, or does someone's height explain a change in age? So the age is going to be the explanatory variable. The height is going to be response. So response is y and explanatory is x. If you struggle to remember them, explanatory has got an x in it, we use the x variable. So here we've got mean height. Height was response. Mean is with a bar, so this is y bar. I find it easiest to write the things down beside them. It really helps us know where they are. So standard deviation of height. Height again was y, so we're looking at sy. Mean age. Age was our x variable, so the mean age is x bar, and sx is the standard deviation of age. R value is the R value. So now what we go do is we put these into these steps here. Now you don't need to write step 1, step 2, step 3, but so that I can match it up with the steps I've showed below, I'm just going to put the 1 there. So the first thing we do is we find B, which is R sy over sx. Plug in the numbers. R value was 0.8827. And there's a times in there, so a times in there. Sy was 13.7961. 7961. And Sx was 1.9024. Going to swap over to a CAS calculator, put that in, see what answer we get. And just quickly doing that on the calculator, we end up with 6.4394. So I've just written that in. The second thing we then do, we have to find out the y-intercept by using this formula of A equals y bar take B x bar. B was now up here, so that's what we're going to use down there. So the mean of y or y bar was 72. Take away 6.4394, and that's times by, or put it in brackets, x bar was 6.4296. Now again, I'm going to go back to a calculator and I'm going to work out what that happens to be. Now, depending how you learnt that, you could have put a times in there. I like putting it in brackets so I know that it's not one continuous number, and we end up with 30.5972. And I've now written that in as well. The last thing we do is go to the regression equation, which is in the form y equals a plus bx. We found a just here, we found b up there, so the equation is y equals 30.5972 plus b was 6.4394 by x. And now we have to then go back and put it in the right variable. So we were saying y was height and x was age. So height, 30.5972 plus 6.4394 by age. Got a little bit small, just had to fit it in there. And just the last thing I'm quickly going to cover, that's what we got if we worked it out by hand. We come back to what we did it on the calculator, 30.489 plus 6.401. They're both very, very similar. They're slightly different because in our second one, we've rounded off. We haven't used the exact figures, so it's going to give us a slightly different answer. So what that means, if you've got the exact figures, do the scatter plot, find your regression line. It will be more precise. But if you're given that information, we don't know the exact figures, that's a method you'd have to follow.